Hello students, my name is Vasanaka and I'm from the Umgungundlovu FET College in Pietermaritzburg. Our topic for today is programmable logic controllers, and hopefully we'll have time at the end to discuss a few examination questions. What I'm going to do first is run you through a procedure to answer typical exam questions, because students normally look at the circuit and it actually looks a bit complicated, and yet it's not. So the first thing we are going to do is, when you get an examination question, is to actually convert the circuit that's actually drawn for the PLC into symbols that you normally know, which are electrical symbols. So this is a typical circuit that you will get in the examination question, and they could probably ask you to explain it. So as we said, the first thing you're going to do is look at what the circuit means in electrical terms. So if I had to now convert it to electrical terms, your start switch would be a normally open switch, all right? Your stop switch would be a normally closed switch, and your motor contactor would be there. This would be M1.1, all right? This is your latch for your motor contactor, so this would be a normally closed, a normally open switch, M1.1. This is another switch associated with your contactor. Okay, this is a normally closed switch, M1.2. So M1.2 would be a closed switch in electrical terms, we know that. And this would represent lamp 2. Okay? We will now look at the third circuit, M1.3, which is a normally open switch, and your lamp contactor 2. So I'm going to draw another open switch. Lamp 2. Okay, and now you can see it's actually going to be a bit easier to understand how the circuit works, because remember, this is my live, and that is my neutral bar. So current will flow, remember, we mentioned top down and from left to right. Let's look at the circuit. I could see normally open switch, yes. Normally closed switch, yes. Normally open, yes. Normally closed, normally open, and my 3 contactors. The second thing you do, all right, is look at what is happening to the circuit before any switches are pressed or before I energize any part of the circuit. What is actually going on? All right. Now, in order to do that, you follow the current paths. If I look at the first rung, all right, I'm going to have to stop at that point because no current can flow past here. So up to there, nothing can happen. If I look at the second rung, up to there, nothing can happen because open circuit, no current flows. If I look at the third run, current can flow right across. Okay, so if I look at lamp 2, it's actually on. And remember now, this is before I actually pressed any start or stop button. If I look at the fourth rung, current can only flow up to that point. Stop there because it's an open circuit. So in the normal state, that is what happens. Okay? I can now proceed to answer any other questions that are asked about that particular circuit, whether they ask you to explain the operation or explain what would happen if the start button is pressed, or explain what happened if M1.1 doesn't energize, etc. The third thing to look at, if you're asked basically to explain a circuit with faults. So let's just say they ask you to explain the circuit here, and okay, we'll leave the same one, it's fine. Okay, what would happen if the stop button does not close? Okay, and then they would say, okay, the second part is 2. What would happen if M1.1 does not energize? And this is after pressing start. Okay, so let's look at the question. After you press the start button, what would happen if the stop button does not close or is not closed or refuses to close? So you will look at that fault and remove that stop button, because now it is not part of the circuit anymore. And you will answer what would happen if the start button is closed. When you are looking at the next question, you replace your start button, or your stop button, and you would ignore this question completely. And now you look at, as if that's the only question, what would happen if M1.1 does not energize? So what would happen if this does not energize? And you would answer the question as follows. The next tip, when you are answering examination questions or past paper questions, as you would like to call it, is when you are given a question to design. All right, I'm just going to read this one here. It says, a ladder logic diagram with a 10-second delay. Design a ladder logic diagram with a 10-second delay on timer and 2 lights. Initially, light A is on, and after a period of 10 seconds, light B goes on, and light A goes off. The timer coil must have 2 sets of contacts, 1 set of normally open contacts, and 1 set of normally closed contacts. So before you can answer the question, the first thing you do is actually look at how many inputs I have and how many outputs I have. So in this case, I have a timer coil. I have 2 inputs, light A and 2 outputs, light A and light B, and 2 inputs, a normally open contact and a normally closed contact. So let's look at it. For an input, if I look at my inputs, so I'm going to, before I even start designing, I'm going to say inputs, I have a normally open contact, and that's that. Okay? I have a normally closed contact. I have 2 lights on my output, so my outputs, remember, I'm going to represent them as coils. Light A and light B. And I also have a timer, all right? So timer will be an output, and we'll say T1 timer, and the time that it said it must time for is 10 seconds. So it will be 10 seconds. I now have listed my inputs and my outputs. I now need to give them addresses so that when I'm designing the program, I still don't make a mistake and repeat addresses. So because these are outputs, they're all going to be Y. So I can say light A is Y001. Light B, Y002. Timer, Y003. Or in some cases, I could just use T1. Now, remember the question said that these normally open contacts and these normally closed contacts belong to the timer, all right? So the addresses for these contacts would be T1, and for the normally closed contacts would be T1, okay? I now have all my inputs and outputs. I have my addresses. I can now continue to design the circuit. Let's look at a typical example, all right? It says, explain the operation of the ladder diagram in figure 4 below. Okay, we have a normally open contact, a normally closed contact, and a coil CR1. We then have a latching contact, CR1. We then have 2 normally open switches, A B, CR2. Okay, end. Okay, and now let's go to the procedure that we mentioned earlier on. We said the first thing you do is in pencil on the side, just draw the circuit using normal electrical symbols. All right, so using normal electrical symbols on the side, I'm going to have a normally open switch, which is normally a start, a normally closed switch, and my contactor. All right, I'm going to have a normally open, which is CR1, CR1. I'm going to have two switches, okay, they've called them A and B. So normally open, CR2. Let's just do it a bit neater. And end. Okay. And then we said, in the normal state, this is what the circuit is, in the normal state. Okay, that is off. So if I look at the first rung, no current can flow there, no current can flow there, no current can flow there, and that's my end. I can now explain what would happen. All right, the question specifically says explain. When you do that, it is also important that you explain in steps. Don't say start with if this is closed or if that is closed. Start in order. Remember what we said is, how does the PLC read? It reads from top down, left to right. So the first, normally this would be a start button and this would be a stop button. So I will say, 1, if the start button is pressed, what would happen? And then you physically go and press it in your diagram. So take your pencil, close it. All right? And you would write here, A. This is your answer now. If the start button is pressed, let's look at what would happen. All right? You can see that current will flow and CR1 will be energized. So you will write that down. If the start button is pressed, CR1 will be energized. Okay? The second thing you have to look for, if a coil is energized, is it going to stay on? So what do we have to look for? We have to look for a latching circuit. Do we have a latching circuit? Yes. There's my latching circuit here because it's got the same address, CR1, as my coil. So I will say, if the start button is pressed, CR1 will be energized and it will latch itself with the switch CR1. Okay? And then what it means, that will close. So even if I now release the start button, current will flow here, my contactor will stay energized. What happens next? All right, just to put the address of this normally closed here, they actually call it CR2. This is CR2, and that's start. Okay? What happens next? Let's look at it. All right, I've finished with the first rung. I've looked at the second rung. My contactor is energized. I have a latching circuit. I can now proceed. If there was no latching circuit here, nothing else would happen. All right, because the contactor is not energized. So now that it is energized and it is latched, let's look at what happens here. What would happen if I close switch A? All right, so if switch A is closed, let's look at it. Okay, current will flow through switch A, yes. but it'll stop here. Okay, so what would happen? If switch A is closed, nothing would change. Because switch B is open. All right, let's go back. Let's open switch A again. What would happen if I close switch B? Okay, so I will say if switch B is closed, once again, will there be any current flow through this contactor? No, because switch A is open. So you stated, if switch B is closed, nothing would happen. Because switch A is open. Okay, and then this actually brings us back to, remember we discussed the AND function. In order for something to work, both A and B has to be energized, and that would be the last option. Okay, if I now close both A and B, and let's close it. All right, you will find that now I will have current flow from my live to my neutral, and CR2 will be energized. So stated, if both A and B are closed, comma, CR2 will be energized. So what if CR2 is energized? Well, let's look at the circuit. Remember that this normally closed switch here is associated with CR2. So actually we should have written it. It's fine now. Should have drawn it like that. So that normally closed switch is associated with CR2. And the moment CR2 is energized, that changes state. If that changes state, it means from closed, it goes to open. What would happen? Okay, you would find there would be a break in the circuit. Okay, CR1 would be de-energized. So if both A and B are closed, CR2 will be energized, comma, or full stop. The normally closed contact CR2 will open, and CR1 or output CR1 will be de-energized. Okay, so you can see that doing it in sequence, first drawing the electrical diagram and then looking at each step from the top to the bottom, you have now completely answered the question because you have now answered the third part of the question. Let's look at another example. Okay, they say, design a ladder logic diagram where two timers are used to turn on two lights sequentially in the following manner. Light 1 should turn on when the start button is depressed. 5 seconds later, light 2 should go off and light 1 should go off and light 2 should turn on. 5 seconds later, light 2 should go off and light 1 should come on. This process should repeat itself. So firstly, we're going to have two lights, two timers. All right, and remember what we said is your lights your timer 1, timer 2, and a start button. Okay, we said first list them all, then remember which are my outputs, and which are my inputs. Okay, we then said you give them addresses. So light 1, I could say, is Y001. Light 2, Y002. For timers, we're just going to call them T, so that's T1, and that's T2. And remember, both timers are 5 seconds. 5 seconds. Okay, so when the start button is pressed, I want light 1 to come on. So let's draw the circuit. Okay, so for my start button, remember it's an input. It is normally open, and I'm going to use X's. So X001. Remember, for all my inputs, we said we're going to use the notation X. For all the outputs, we're going to use the notation Y. So I'm going to draw my start button, and okay, now you can see, if I depress the start button, all right, what would happen? The contactor here for light 1 would energize, okay, but we did not hold because I haven't included a latching circuit. So immediately now, Y001 must latch itself, so I will include a normally open circuit here, a normally open switch here, which I will also call Y001, because this latch must have the same address as my contactor. 5 seconds later, I want that to actually turn off. So I'm going to have a timer. Something must start my timer, and I'm going to call this T1, and timer 5 seconds. When do I start the timer? Okay, as soon as the light comes on. How do I know the light is on? Y001 is energized. So once again, Y001 will start the timer. The address of the switch would be Y001. What happens after 5 seconds? Okay, after 5 seconds, the timer must start light 2. So this would be light 2. Okay, what starts light 2? The timer T1. So this normally open switch will have the same address as timer T1. Okay, now it also says that timer T1 switches off light 1. How do I switch something off? I break the circuit. How do I break the circuit? Okay, by having initially a normally closed switch, all right, and calling it T1, the same address as timer 1. So if timer 1 is energized, 2 things would happen. 1, it will switch on light 2. Secondly, it will break the circuit here and switch off light 1. Now, let's look at, after light 2 is on, they want another timer to time for 5 seconds. So this would be T2, 5 seconds. I will call this, remember don't forget to put your addresses. So what would switch on timer T2? Okay, it would be light Y002. And you find now, once the light 2 comes on, T1 turns it on, it turns that off. Okay? But it also at the same time starts timer T2. Don't forget, T2 or Y002 will only stay on for as long as it latches itself. So I should have actually put in latch. Always don't forget. So this would be Y002. And then now this would be T2, 5 seconds, and the address for here would be Y002. So Y002 latches itself as well as turns on timer T2. What happens after another 5 seconds? Timer T2 energizes, okay, and we want it to turn light 2 off. So just like we did T1 turning light 1 off, we're going to put a normally closed switch here, and we're going to call that T2. So after 5 seconds, T2 would actually switch light 2 off. But they say this process should repeat itself indefinitely. So indefinitely means to start the whole process again, I must not press the start switch. It must start automatically. How would I do that? Well, you'll find once I reach the stage, timer T2 has timed 5 seconds, it switched this light off, I want to switch. So basically I need to go back to the top and switch this light on. Now if you remember previously we discussed the OR function. So all I have to do here to say that I'm just going to create some space. And this switch can also switch that light on. What would be address of this switch? It would be T2. Okay, so meaning that after 5 seconds, this timer energizes, it now closes this, and it can switch on light 1 again, and the process will continue indefinitely. And the only thing that you need to add is your end statement. All right? They have not asked you to put emergency stop, etc. But just in case they did ask you to put in a stop switch to stop the whole process, what you would do at that point remember, that's T1. At that point, you will put in a stop switch, okay, and that would be stop. Okay, so I hope you understood the procedure for the design questions. Always, please, start with listing your inputs and outputs. Give them their respective addresses. Always, we're using the X notation for inputs and the Y notation for outputs. And always put your addresses at the top, okay? Because your addresses are what the PLC actually understands. Unfortunately, I wish we had time to discuss a few more questions. I've listed quite a few here for you, but due to time constraints, we're going to have to leave it for the next time. I hope to see you soon. And please remember, keep safe, sanitize, stay home, and look after yourself. Thank you.